Suppose you wish to purchase an annuity where payments increase every year after the first by some fixed number g. For example, at the end of the first year, it pays out R dollars. At the end of the second year, it pays out R dollars plus g. At the end of the third year, the previous year's payment again increases by g, and so on. To calculate the present value of such an annuity, we use the following formula. Notice that the variable R here represents the initial amount after the first period. G represents the growth for each subsequent period. PV sub n take away 1 represents the present value of annuity, and we've worked with this formula before. It's shown underneath. And the rest is as shown. Leave a comment in the comment section if you would like me to create a video for its derivation. Now, to show you how to work this formula, let's take a look at a real-life example. The question reads, consider an annuity that increases annually, starting with a payment of $1,000 at the end of the first year. Each subsequent year, the payment increases by $100, continuing this pattern for 10 years. The final payment, made at the end of year 11, will be $2,000. What is the present value of this annuity, given an annual interest rate of 10%? Remember that the value of n represents the total number of periods. It is clear from the description that n must be equal to 11. Furthermore, we're starting with a payment of $1,000, so our R value will be $1,000. Our value of G is $100. That's what it increases by every year. Our interest rate is 10% annually. So here, I will equal to 0.1. 10% divided by 100%. We have everything we need to plug it into this formula. So, the present value of this annuity is equal to $1,000 plus 100 times this expression filled in. I'll open up brackets. 1 take away 1 plus decimal 1 raised to the power of negative n. But remember, it is PV sub n take away 1. So whatever our n value is, 11, we subtract 1 from it, and so we have negative 10. And that's over 0.1. So we just filled in this part of the equation. Then we subtract, in parentheses, again we have 1,000 plus 100 times n take away 1. N is equal to 11, take away 1 is 10. That's being divided by 1 plus 0.1 raised to the power of 11. Close. And all of this gets divided by I, which for us is 0.1. Now, in order to compute this properly, you want to avoid calculating it in chunks. You want to write this entire expression into your calculator as a single step. Let me show you how that's done. So, we'll open up a fraction. So we have 1,000 plus 100, open. We'll open up another fraction, 1 take away 1.1, since 1 plus 0.1 is 1.1, and we'll raise that to the power of negative 10. At the bottom, we'll put down 0.1, and we'll close the bracket. We subtract this now, open again, and we'll open up another fraction, 1,000 plus 100 times 10, close, and at the bottom we'll write down 1.1 raised to the power of 11. At the very bottom of that, we divide by 0.1. And we end up with an answer of 9,134.69. This is what the present value of such an annuity is today, if it were to be purchased now. Thank you for watching, and if you have any further questions, leave them in the comment section below.